All right, thank you very much. Let's give a hand for the DerbyCon staff. All right, welcome everybody. The title of our talk is Here Be Dragons, the Unexplored Land of Active Directory Access Control Lists. About us, this is me, I'm Andy Robbins. I'm the Adversary Resilience Lead at Spectre Ops. I'm a co-creator and developer of the Bloodhound project with these two guys. I've spoken at conferences, I've given trainings. I think I'm a friendly guy, so come talk to me if you want to know more.
I'm Rohan. That's not actually my job title. Andy's messing with me. I've spoken at a bunch of conferences too. I think my only real claim to fame is Bloodhound though, so that's what I'm here to talk about.
I'm Will, I'm Harmjoy on Twitter. I've written a lot of code, talked at a few cons. This is about my third or fourth time talking here at DerbyCon. It's one of my favorite conferences. It's awesome. Definitely come, grab us in the lobby or something after. We love talking about all this kind of stuff. I'm also an active trainer, Black Hat, and some red team training, offensive Active Directory, some of that stuff.
This is where we work, Spectre Ops. We think it's a pretty cool company. If you want to know more about the company, come talk to us. Find somebody in a purple shirt like this. So the outline, this is what we're going to go through over the next 50 minutes. We're going to talk about prior work. We'll talk about why you should care about this as a defender or an attacker. We're going to start speaking the same language and kind of give you a background on ACLs. Yeah, raise your hand if you have an empty seat. That's okay. That's all right. Fantastic. So then we're going to talk about how do we abuse these misconfigurations, and then we're going to flip it around a little bit. We're going to first talk about how to abuse them, then we're going to talk about how to find them, and hopefully that's going to make sense when we go show you why. We're going to do a Bloodhound Interface demo and show you the new features in the Bloodhound Interface that are ACL related, and then we'll do a very complex ACL only attack path at the end to kind of drive home how this all works.
Saying it's operationally focused this time.
Oh yeah, so Will and I gave a talk that was focused on backdooring Active Directory using ACLs at Black Hat and DEF CON this year. This talk really, if you don't know what ACLs are, if you're a pen tester and you want to start using these on your pen test, this talk is for you. If you're a defender and you want to know how to be prepared for these kind of misconfigurations, how to find them, this talk is for you as well. So this talk is very practical. It kind of borders a line between a workshop and a talk. So we're not going to cover a lot of theory, and it's going to be very, very practical and operationally focused. Some prior work we want to acknowledge really quick. The Heat Ray project from Alice Jung and John Dunnigan at Microsoft. Active Directory Control Paths by Luca Boyot and Emmanuel Gras. These two projects were very, very heavy influencers for the Bloodhound project at large. Active Directory ACL Scanner by Robin Gramberg. Airbus BTA by Philippe and Joffrey. I'm not going to try saying their last names. And then, of course, no Active Directory security talk is complete without mentioning Sean Metcalf. Is Sean in the room? I don't see him. If you see Sean, shake his hand, give him an applause.
One thing I want to ask really quick, who uses Bloodhound on a regular basis?
Sweet.
That makes us happy.
Awesome. All right, so why should we care about this? Why should you stay in here for the next half hour and not leave? So there is a general lack of awareness, in our opinion, with this entire attack surface in general. A lot of this is on us as attackers and on defenders, but a lot of it is also on third-party developers and on software installers that make changes to the Active Directory schema and alter the privileges against other securable objects in Active Directory. By far the largest offender of this is Microsoft Exchange Server. Prior to Exchange Server 2007 SP1, Exchange Server would modify the securable objects in Active Directory to give every Exchange server the ability to take over any other object in AD, including domain admins, the domain object itself, etc. Versions prior to that just gave it direct control over everything in the environment. So if you got access to an Exchange server and you were able to enumerate the ACL relationships from that server outbound, you would see that that Exchange server is just as sensitive as a domain controller because it has access to literally every other object in Active Directory. You want to talk about misconfiguration debt?
Yeah. We started kind of coming up with a term for this. There might be a term already out there, but we like this phrase, misconfiguration debt. Because if you had an old installation from years and years and years ago, so you had a very old install of Exchange, like Andy mentioned, that had these really bad ACLs, And even if you upgrade, and even if everything's locked down, a lot of those ACLs will persist in your environment for years or even decades. So these often survive domain functional level upgrades because new installs aren't going to go back in and actually repair and muck with all of the access control entries from previous objects. So this debt of misconfiguration will start to build up, and it has been building up for years, and we just haven't realized it collectively. And part of that is because it's been very difficult to audit these components at scale. And you kind of have to have graph theory to actually execute these types of things at scale, because one particular ACE misconfiguration might not seem like a huge deal, but in the context of an entire attack chain, which will show, then it can become a path to complete domain compromise.
So additionally, to find these misconfigurations, you need to be a domain user. That's all the authentication you need in the directory to be able to find and enumerate all these misconfigs. In most of the attack paths that you're going to find, you're only manipulating objects in Active Directory, so you're doing LDAP to a domain controller. So what that means is that by and large, all of these attack paths, you don't need to pivot to another computer to like run mimikatz or impersonate another user. So network segmentation doesn't matter. If you can talk to a DC, you can execute these attack paths. Guess what can communicate with the DC? Everything during the domain, right? And then finally, so there's a completely different forensic footprint left behind by these attacks. And in general, most organizations, in our opinion, are completely unprepared for these kinds of attacks. Here's a tweet from Javier. He was replying to Captain Jesus, or Rohan, in a Twitter thread. So he says, in a recent offensive assignment, we found that AD ACLs has been modified for a DA level persistence, but not by an attacker, but by IT people. So Javier has seen this. Other colleagues in our field have seen these misconfigurations. We have seen them in real environments. They are real. They are dangerous. Here's the Bloodhound interface. This is showing you the vanilla derivative local admin attack paths from any user to the domain admins group. So there are a number of users that have an attack path to domain admins. This is before we add in the ACL relationships. After we add the ACL relationships, this changes to this. There's an order of magnitude more principals in the directory that have an ability to take over the domain admins object and therefore take over the entire directory.
And one thing to note here is that in this particular view, we're showing that derivative local admin for, who has administrative access, sessions, all those original components, combined with the ACL information for a complete contextual graph. We are going to talk about ACL only attack paths, which we'll cover, and there are ways to enumerate just ACL only components. But also when you mix that in with the existing Bloodhound information, that's when the graph really explodes.
All right, so let's get on the same page. Let's start speaking the same language and talk about ACL background. So an ACL is applied to a securable object, or more appropriately, a discretionary access control list is a property of a securable object's security descriptor. A security descriptor, or the definition of a securable object in Active Directory, is any object that has a security descriptor. The security descriptor, or the SD, is comprised of three things. One is who's the owner of the object. Two is the discretionary access control list, which describes what principals have what privileges against that object. And then secondly is the SACL, or the System Access Control List, that describes how events against this object are audited or logged. Here's what it looks like in the GUI. Who's seen this GUI? Everybody's seen this GUI. You go to ADUC, you look at the security properties on an object, you go to Advanced, you get this. This is the GUI for the security descriptor. This is an ACE, or an access control entry. This ACE says that the administrator's group is allowed full control over this object, which is the user account called Waldo. So how are these things put in? By and large, there are three primary ways that these get added in. One is through third-party software installations that are making these changes automatically behind the scenes that you may not know about.
Think like a third-party Active Directory administration software, right, that decides to push the easy mode button and just add themselves, complete generic all to everything.
Two are like one-off changes that an admin makes, like knowing what he's doing or not. And then three is this. So this is the delegation of control wizard. This wizard is being used to delegate control to any user object within the user's OU to say they can reset the password of any user within this OU tree, which means that they can change that user's password without knowing its current value. It's the help desk privilege. Once you do that, that's reflected like this on the security descriptor. So the help desk group has reset password against the user Rohan Berserker. So everybody understands ACLs 100% clearly. All of us are on the same page now. If you want a little more in-depth information, so we're just trying to go quickly here so we can get to the interesting content. We have a 67 white paper, 67-page white paper, written by Will, Lee Christensen, and myself. It's at that link. Go read it if you want more in-depth info, and if you want to see how to use these for very, very sneaky persistence in Active Directory. All right. So how do we actually abuse these? We have all these different rights against an object. There are many of them. We have trimmed this down only to the ones that are actually relevant for taking over another object. So first of all, you have the force change password privilege. Any computer, user, or group on the left can have this privilege against a user object on the right. So this means that I can change that user's password without knowing its current value. Will has created several power view commandlets for abusing these misconfigurations. The relevant abuse commandlet here is set domain user password. After you import PowerView, run git help set domain user password, or do that for any PowerView commandlet, and you can see exactly how to use the commandlet. We'll also show you a good example of this in the demo. Cleanup method. So I'm actually not going to talk about this right now. I'm going to talk about this later. So think about it's insane. But just kind of like as we're talking, think about how you would actually clean up after yourself with changing somebody's password. Add members means that I can add a member to a group. The PowerView commandlet here is add domain group member, so I can add an arbitrary object or arbitrary principal to the members of a security group, and then obviously whatever privileges that security group has, now I have it as well. If I want to clean up after myself, I can just do remove domain group member, and that step is cleaned up. Generic all is full control. It means that I have complete full access to the object. This is what domain admins has to every other object in the directory. Against users and groups, you have basically three options, 2 for users, 1 for groups. For groups, you can add people to the group. For users, you can change their password, or you can do a targeted Kerber roasting attack, where you set a fake service principal name on that user object, and then use Kerber roast to request a Kerber roast ticket for that user, and then crack that ticket open, and if you can do that, you can recover the plain text password for that user. By a show of hands, who is using Kerber roasting on your engagements frequently? If you're not using Kerber roasting now, I highly encourage you to do so. It will change the way you operate fundamentally. It's insane. Generic write means that I have the ability to write to any non-protected attribute on the object. So for groups, I can write to the members property. And for users, I can write to the service principal name property and do that targeted Kerber roasting attack once again. And then here are the associated PowerView commandlets again. Write owner. So this is interesting because the owner of an object maintains full control of that object regardless of what the DACL says. So even if I have a deny ace at the very top that says domain admins are denied anything on this object, if domain admins still owns that object, they can still do whatever they want. So if I write the owner to myself, now I can do whatever I want. With PowerView, the commandlet is set domain object owner, and then the cleanup is the exact same one, just set it back to what it was before. Write DACL means that I can write a new ace to the DACL on that securable object, and I can just give myself whatever privilege I want. In PowerView, you do this with add domain object ACL, and the cleanup is remove domain object ACL. Does that seem pretty simple? Yeah. I think Will has done a lot of work to make this like as operational and as easy to do as possible, I think.
And again, you can do this. You don't have to use PowerView. We're just used to using the tool set, and we decided to write really easy commands for every single primitive.
Next, we have the all extended rights privilege. This means that we have any privilege that is defined as being an extended right in Active Directory. This includes resetting passwords and adding people to groups. So you can see kind of a pattern here that either you can change someone's password, Kerber roast them, add someone to a group, or you have all these other privileges that can get you there, right? So those are the primitives. Those are the commandlets that are associated with them. So how do we actually find these misconfigs? For this, I'm going to pass it over to Will.
And one thing to mention, there are obviously a few select object takeover primitives that we didn't cover. We still have some work to do for the Bloodhound interface, so specifically DC sync and GPO edit rights are next up for us to actually integrate into the graph. So we only covered the ones that are functionally, operationally implemented in the Bloodhound ingester and analysis platform. So there's a couple different ways you can start to enumerate this stuff. You can do spot checks with PowerView for like singular object inspection. We still do this now for the control relationships that we don't have integrated into the graph yet. Specifically, the DC sync on the domain object, on select GPO type things, and I'll show some examples here in a second. Then we're also going to show how you can use Sharphound, which is a brand new Bloodhound ingester. I wrote the original version, the PowerShell ingester that everyone's been using. I know if anyone has had issues with the project, it's almost always been because my code doesn't like to run at scale necessarily, because PowerShell version 2 doesn't quite have a threading model, and it's, we had to do some hacks to jump around stuff, but Rohan's done some amazing stuff with the new Sharphound ingester, and he's going to go over a bunch of the new details for that. And then Andy is going to show how to take that data that was collected at scale and actually use it through Bloodhound to find some of these attack paths. And again, we're focusing on domain privilege escalation at this point. We're not focusing on implementing these for a persistence perspective. So again, while graph theory is pretty much necessary to audit these components at scale, it still can be useful for those one-off spot checks. And you can use different tool sets. I'm sure you can use some DS query, some old school stuff. And again, because we're such a heavy PowerShell shop, we decided to write the tools how we wanted to use them. So we started implementing this type of functionality in a way that made sense to us in PowerView. So the function is get domain object ACL. This is our go-to. This will return all the ACE entries for a particular object that you want to enumerate. Also, if you're not aware, if you do the tac resolve GUIDs flag, this will actually resolve in the for schema all the GUID mappings to their human readable names. So instead of the super long GUID, it'll tell you, force change password or write members or things like that. So that probably should be on by default, but if you're ever playing with this, always remember the tac resolve GUIDs. So for example, who can DC sync? You can import PowerView, get domain object ACL on the domain object itself, because a domain is actually represented as an object within itself. So that DC, test lab, DC, local, the distinguished name for the domain, we're going to resolve the GUIDs, and then we're going to filter and say, show us where you have for the ACE entry, the principal or trustee has replication rights or generic all rights. And you start to see these SIDs popping up. So this particular SID, or the security identifier for a built-in actually has these generic all rights on the domain itself and can therefore DC sync. Another interesting one, I put a post up about this last week. If you want to figure out who can actually edit a group policy object in a foreign domain, you can use PowerView as well. So enumerate all the ACLs, or enumerate all the GPOs in dev.testlab.local, resolve all the GUIDs for these ACE entries on the GPOs, and then see where the security identifier is over 1,000, so it's not built in. We're kind of tuning this noise down so we can actually try to find more interesting results. And where the rights are right property, generic all, generic right, right DACL, right owner. So these are those object takeover primitives. And then we're going to pipe it to a for each block and actually give us some more contextual information and actually resolve those SIDs to human readable account names for the object. So you can just run this. We get a nice collection of all the non-built-in users that have the ability to edit a GPO. Then we can tie that back in with PowerView and figure out where that GPO applies. Because if you can edit a GPO, you can push malicious settings that then can result in takeover of any computer or user is applied to. This will be integrated into Bloodhound. It's going to require a custom pathfinding algorithm. It's definitely harder than we thought. So it's on the docket. It has been in the forefront of our mind for the last couple of months, but hopefully by the end of the year, I think we can probably get it in. This is the next big thing up, because we know this is going to explode the graph even more.
All right, I'm so excited about this. I could probably talk about an hour just by myself, but I'm not going to. As Will mentioned earlier, we have been slowly rewriting the entire ingester into C#. With rewriting it, we basically got to implement all our pipe dreams, and we basically got to write it with real threading instead of run spaces. Will did an awesome job with the original ingester. The amount of work he put into it was crazy, but he was limited by PowerShell. So we decided to just scrap it. Yes, version 2. So there are tons of new features. The biggest thing to take away is that the performance is literally orders of magnitude faster. I have some speed comparisons for you. I'll show you in a second. A big problem a lot of people had when they were using the ingester was how much memory it used. I know that we've had people tell us I allocated 96 gigs of memory for the ingester and it used all of it and then crashed. So we spent a lot of time focusing on how to fix that. And we got the memory usage down to about 200 to 300 megs tops. So regardless of what environment you're running it, even if you end up on like some Windows 7 computer with 500 megs of RAM, you'll probably slow it down to crawl, but it'll probably still work.
We have people that have run this in a domain of hundreds of thousands of nodes that have been testing betas for us, so it'll work. Yep.
I think the biggest we've seen so far was about 350,000. So it's getting there. So yeah, more and better threading. Previously in the old PowerShell ingester, the session enumeration, local admin enumeration was threaded. Well, we decided more threading for everyone. So now the group collection and ACL collection is also threaded. The speed increase there is humongous. On larger domains, group collection could take forever. We didn't like that. We like going fast. So modular stealth enumeration. Before we just had a stealth collection method. We didn't really like that either. So now you can do things like, I want to collect local groups using stealth collection. I want to do sessions using stealth collection. You can individually specify what you want to collect and the way you want to collect it. Session looping. This is something we suggested to a lot of people, is that once you started running your ingester, put it in a loop, keep collecting sessions. Then we said to ourselves, why are we putting it in a loop? Why not just write a session loop? So now we have it. There's a whole new collection method called session loop. You just run it and you tell it how long you want it to go, how often you want it to loop, and it'll just keep collecting sessions for you and spit it out into a file. It's awesome. Caching. This is a big one. Every time you run SharpHound and it finds new objects, it saves it to cache. Whenever you try to enumerate that object in the future, it'll pull it from the cache instead of pulling it from Active Directory. That means each time you run SharpHound, it gets faster as it gets more data. Additionally, the network overhead is significantly reduced because there's no more resolving objects over and over and over again.
You can disable the caching if you want. Say you're on an offensive gig and you want nothing touching disk, but by default, it'll do the
it just drops a small bin file, and that's your cache. Progress output. I put like 50 exclamation points behind it because a lot of people were annoyed by this, that when you were running Bloodhound, you had no idea if it was actually running. Well, now every 30 seconds, it spits out how far along it is. It'll tell you how many objects it's enumerated. Tagging onto that, there's no more individual collection methods. Everything runs at the same time. So when you tell it to enumerate, it's doing groups, sessions, local admins, all simultaneously. So you don't have to do groups and sessions, then local group. We even implemented locale independent local admin enumeration. We had someone tell us they ran it in French domains today and it actually worked. This is the first time I knew it worked because nobody told me.
Administrateur.
Yeah, so administrateur is now collected properly, as is administrator. So there's a lot of features. I got a blog post I'll give you a link to later. But here is what you guys care about, the speed improvements. So you have old ingester and SharpHound.
These are from real world networks.
Yes, this is a real domain. We got these, like last week? We wanted something cool for the deck. So you can see group collection went from 1:10 to 19 seconds. Local group and sessions, we cut it down probably about a fourth of what it was, if not more. ACLs from 10 minutes to 37 seconds. So operationally, this is going to be a really big deal. I have a little blog post written up with all the new features and all the cool new hotness in SharpHound. That's the link to it if you want to go check it out. And my favorite picture in this entire deck. This is an accurate representation. Thank you.
Go ahead, Rohan.
And I want to give a huge shout out. We have a Bloodhound Slack channel, which I encourage all of you to join. I've had a small group of users happily beta testing this for me, running it in their real environments, even though I told them that they have no idea what's in the code. And they trusted me enough to do it, and SharpHound would not be what it is without these beta testers helping us find all sorts of bugs and test it in real environments.
So it's been 3 months of just features, mods, tweaks, and like this testing cycle for like 3 to 4 straight months.
Yep, there would be days when I would drop 4 or 5 different builds of Sharphound, and people would happily step up and test it for me over and over again. So I love you, beta testers.
Cool. Okay, so what we've got next is we're going to demo the interface additions, or interface additions. So in the Bloodhound interface, we already had the ability to figure out where does somebody else have local admin privileges, either by explicitly having those defined, like that user is defined in the local admins group on a computer, or by security group delegation. So I belong to this group, that group belongs to this group, that group has local admin rights. We can graph that out now in the Bloodhound interface, and we've been able to since we dropped it at DEF CON last year. So outbound privileges is very easy to audit with Bloodhound, and also inbound privileges as well. So for any given computer object, you can see who are the explicitly defined admins, who are the unrolled admins, and you have all kinds of other cool stuff like pathfinding and hunting for user sessions based on security group, and all kinds of other kind of like cool stuff. So what is new? So here is the Bloodhound interface when you first bring it up, and I'm going to try to pause this if I can. Oh, you just click on it and then it pauses it. Cool.
Oh, no.
Yeah, it does.
Okay,
Yeah.
cool.
All right. So when you first pull up Bloodhound, the default view is it will find any group that matches like star domain admins star, and then show you who the effective members of that group is, either like directly or through unrolled security groups. So going to the bottom of the screen there, where you have the inbound object control. So what I'm going to look at is for a domain admins group, so this domain admins at internal.local group, who actually has control or the ability to gain control of this group. And we have this broken out into 3 different sections. The first one is explicit object controllers, and the number here is 6. So if I zoom out a little bit on here, you can see that I have these 1, 2, 3, 4, 5. I have 5 groups, and there's a user that didn't get drawn correctly, but I have these groups right here that have generic all, and then at the very bottom, right DACL privilege against the domain admins group. So the domain admin security descriptor is going to be cloned off of the admin SD holder security descriptor. That has some idiosyncrasies or some ways that can actually have that not actually apply to all the security or the securable objects that it should. Which I'll show you a real scenario in the next demo. But anyway, here are the first degree controllers of the domain admins group. But these groups are going to have members of them, right? So if I want to see who are the unrolled users of all these groups, I just go to unrolled object controllers on the left and click the 29. And then the interface will draw that out. And I can see all these computers, all these users that have effective immediate control of the domain admins group. There are some Exchange servers in there as well, so that Exchange trusted subsystem that I mentioned before, that's the security group that Exchange server adds when you install a server in Active Directory, and then gives that group full control over almost everything in the environment nowadays, and then adds the Exchange computers to that group. So a very, very sensitive group. Now, what about ACL-only attack paths that get me to the domain admins group? So the phrase that we came up with for this, which actually Jared Atkinson helped with, is transitive object controllers. So if I have control of Will and Will has control of Rohan, I have transitive control of Rohan, right? So back in like Algebra 101, like the law of transitivity, right? So I can do transitive object control, and that number is actually 50. So here are all of the principles that have some kind of attack path getting to the domain admins group. So all those users there belong to this group called identity admins, which is a member of this group called account operators. That group can change one domain admin's password, and then that user is obviously a part of the domain admins group. So what about a little more interesting attack path? So we'll go a little bit further to the left. We have this user that is a member of this group, which is a member of this group. That group can change this user's password, who can change this user's password, who is a member of this group, and that group has generic all control over the domain admins group. It doesn't matter how long or complex these attack paths are, Bloodhound will find them very, very fast.
Doing this by hand with spot checks, you can now start to see you're going to miss a large number of these different types of branches.
Yep.
Also, these are real. This isn't like something we just made up out of, well, we kind of did, but we've seen attack paths like this in the wild on real environments. This is not like, this isn't just like fake to make you guys go ooh and ah.
Yeah, this is not fake news. Like the screenshots I showed you earlier are actually from a real environment. Obviously the labels were hidden. And so obviously this is a little bit contrived, but it is based on what we've seen in the field. So what about outbound object control? So if your CIO came to you and said, what control does this user have over other objects in the directory, how would you answer that question? With Bloodhound, it's incredibly simple. So I'm going to find this user here called rtaylor. I'm going to click on him, and that'll populate the user tab with some useful information. So now I'm going to go to outbound object control and see what other objects this user has control of. First of all is first degree object control. This means that this user rtaylor has been added as a principal on an ACE on another object. That's pretty rare. So in this example, we kind of mimic reality, and we don't have that example. However, this user does belong to groups, which may give him control over other objects. And so that number is actually 4. So he belongs to this group on the left here called Migration G. And that Migration G group is a member of this group called Backup 10. And that group has force change password against these 4 users right here. So let me expand that out further and do transitive object control. So if I just carry out that ACL only attack path as far as I can, and recall that I'm only manipulating Active Directory objects, I'm not pivoting to systems or doing anything like that. Here are all the other objects that this user has effective control over by executing an ACL only attack path.
And if you're on an offensive engagement, and you land, you fish, you hit an initial guy, right? Your initial foothold, and you're able to run this collection just talking to a DC, then you can see from that machine, without getting remote code execution in any other box, all the principles you could actually take over from your offensive engagement.
Yep. Okay. So, how are we doing so far? Is everything kind of gelling, making sense? All right, cool. All right. Thanks. So let's look at a attack path, and this is based on an attack path that we have seen in a real environment. All right, so the default view, we pull up Bloodhound, we see the domain admins group. What we want to see is what are the shortest paths to get to the domain admins group. This button right here that I just clicked on the thing that looks like the stock market going up, this is like the most underused button in the interface, which is unfortunate because it changes the layout from force directed to hierarchical, which makes it a lot easier to read and understand. So in the top part of this window here, which I'll zoom into, you have like your classic vanilla derivative local admin attack paths. Those users on the left belong to a group that has admin rights to those computers, and those computers have domain admins logged onto them. So obviously, through the power of Mimikatz or through user impersonation, I can pivot to one of those machines and then become a domain admin by stealing the creds or impersonating them. On the bottom, I have ACL only attack paths. So this user, J. Frank, is a member of a group called Helpdesk Tier 1. Helpdesk Tier 1 has the ability to add members to a security group called User Setup. User Setup has 2 different control relationships to all the users in the group called Account Operators. So it has generic all, so full control, and it also has force change password. So at this point, I have a choice. I can either change someone's password, or I can do a targeted Kerberosing attack against one of those users. Then once I know one of those users' credentials, I now have the access of the Account Operators group, which has the ability to change the password on one domain admin, which again, we have seen in the real world. And then of course, the JDMIC user is a member of the domain admins group. Okay, so let's show how to actually execute this. So here are our attack steps. Step 0, we want to determine whether or not we have a Kerberosable user in our attack path, because we want to avoid changing user passwords as much as we possibly can. Then we're going to add J. Frank to that user setup group. And with that privilege that we now have of that group, we're going to Kerberos one of those users in that group and try to recover their plain text password. Then, once we have that guy's password, we're going to change JDMIC's password and we're going to snag the KERB-TGT hash, which will give us the ability, obviously, to roll golden tickets. So, attack step 0. We want to determine if we have a Kerberosable account in our attack path. For this, we're going to import PowerView into a Beacon session, and Beacon is running as that JFrank user, that initial user in the attack path. So we're going to import PowerView in this Beacon, and we're going to enumerate the users of that group called account operators. Then we're going to pull out the same account name and the password last set parameter from each of those users. So we're going to see how old each of them, each of their passwords are. Now let's take a look here. Oh boy. So Jay Atkinson, hey, thanks for the phrase, but your password, procedures are really bad, man. So Jay Atkinson hasn't changed his password since 2011. So maybe there's a chance that we can crack his password. And spoiler alert for the demo, it's crackable. Okay. So now we want to do a targeted Kerber roasting account. So we need to add JFrank to that user setup group. That's going to give us that privilege to edit the properties on the Jay Atkinson user object. So this is very simple. Again, we're doing add domain group member. The identity switch is for the group that we want to add somebody to. And the dash members is who we want to add to it. So we're adding JFrank, and it's done. So now JFrank is in that group, and he has all the same privileges that that group already had. So attack step 2, we're going to add an SPN to the Jay Atkinson user, and then we're going to Kerber roast him, and we're going to recover his plain text password. So recall, user setup has force change password and generic all, but we're going to Kerber roast so that we minimize our password reset activity. To add the SPN, we will use set domain object, and the identity is going to be the user we're adding this to, so it's Jay Atkinson. And then what we're going to do is we're going to set service principal name to just a garbage value. So it's just going to be blah/blah. It doesn't actually matter what this property is. As long as it follows that foo/bar format, you'll be able to request a Kerber roast ticket for that user. So now that's done. And so now we're going to Kerber roast this user. So in PowerView again, you have this commandlet called invoke Kerber roast, and identity is going to be the user that we're requesting a ticket for. And then we're going to extract just the hash out of the resultant PS custom object that comes back. So here is the Kerber roast ticket for Jay Atkinson. Now that ticket is signed and encrypted using his NT hash. So whatever his current password is, if we can guess what that is, we can open the contents of that ticket and we know that we have his password. We'll use John for this, and oh boy, oh Jared. So password 1, the biggest crime in info security.
That's not real. No one uses that in real life.
Oh yeah. So now we want to clean up after ourselves. We don't want Jared to look at his SPM property and be like, oh my God, what is this? So we're just going to clear that using the set domain object parameter again. And we need to do this while we still have that privilege. So after we do this, then we're going to remove JFrank from that security group using the remove domain group member commandlet. So you can see as we're going through this, we're cleaning up after ourselves along the way. And that's done. So now we have Jared's plaintext password, and the environment is in the same state that it was before we started. Now we're going to change JDimic's password, and then using his domain admin rights, we're going to get the curb TGT hash. So Jay Atkinson, as a member of the account operators, recall that he has force change password ability over the JDimic user, so he can change his password without knowing what it currently is. How are we on time? We got 10 minutes? Perfect. All right. So here is the way that you do this with PowerView. So I'm not going to go too far in depth into this, but the bottom line is you have 4 different steps to actually do this by providing alternate credentials. But in Beacon, you can't supply a variable in PowerShell and then have another PowerShell instance spin up and have access to that variable. So instead, we're just going to convert this all to one line by separating them with semicolons, which looks like that. Then we're just going to copy all that content, and then we're going to paste it into our Beacon, and that's going to follow all of these steps. And the result is we're going to change JDimic's password to password123 bang. So we executed, and we're done. So password for user JDimic successfully reset. Now we know the clear text password for a domain admin. So what we're going to do next, we're going to make a token. We're going to impersonate JDimic in our beacon. Then we are going to use PS inject, or not yet. So first we're going to use DC sync, and we're going to get the curb TGT NT hash. And now we're done. So we have the NT hash for the curb TGT. Now we can create our own tickets for any other user in the domain. We can create golden tickets. And we also have an extremely good persistence mechanism in AD. We own Active Directory now. We own the entire domain. Now we're going to get JDimic's password. We're going to look at what it is now and then also what it was. So for what's highlighted here, that's what we just set. So that's the NT hash for password 123 bang. The first entry in the NT history, that's what his password was before we changed it. So we can get this information from DC sync. Benjamin Delpy and Vincent Latou recently put in work that you can reset somebody's password using NT hashes, and you can bypass the clear text password check that the directory service agent performs to make sure that the password complies with password complexity requirements. So we are not necessarily injecting the NT hash back into NTDS, but we're passing it off to the local SAM functions on the domain controller to do that for us. There is an important caveat on that I will talk about after we're done with this demo. So we have a custom version of Mimikatz that Rohan rolled a few nights ago. So the command here, we're going to do LSA dump change NTLM, and we're going to specify the domain controller that we want to do this action against. Then we'll specify the user that we want to change a password for, it's JDimic. Old NTLM is what its current password is, so that's what we changed it to. So we'll copy that and then paste it. We have 8 minutes. New NTLM is what we want to change it to, so that's actually going to be what his password was before we changed it. So the next time he logs on, he's going to be able to authenticate correctly to the directory. He's not going to get a bad password error. He'll be able to use what his old password was. We'll let that run. And his password is set back to what it was before. That's it for that video. Now, one important caveat that you should be aware of. So Benjamin Delpy and Vincent Latou, obviously, their work is incredible. They are working on other things to make this process a little more OPSEC safe. So the process that we just did where we injected the old NT hash as that guy's current password, that is going to bypass the clear text check. However, it is not going to bypass the password history and the minimum password age requirement. However, Vincent is currently working on a project for, instead of pulling information from a domain controller with DC sync, of pushing information to a domain controller, which I believe will bypass that password history check. Until then, what you could do is set a fine-grained password policy that affects just that one user so that you bypass the password reuse and history requirements, then go through all that and then remove the fine-grained password policy. Future work, we want to have more options for taking over computer objects. We are continuing this research. We would love to hear your ideas if you have ideas. Laps is an obvious choice, and we have work on that effort underway already. Talked about temporary fine-grained password policy as well. Will mentioned the addition of GPOs into the collection and the graph as well soon. Thank you very much. I am @_Waldo on Twitter. Rohan is Captain Jesus. Will is Harmjoy. We have stickers up here at the front if you would like a sticker for Bloodhound or for Spectre Ops. If you're not already in the Bloodhound Slack, I would highly recommend that you join it. We have conversation about Bloodhound, and then also it's kind of turned into an extremely active red team general conversation Slack as well. We have almost 600 people in there right now, so you're going to find interesting conversation in there. And then if you want Bloodhound, bit.ly/getBloodhound. If you want Sharphound, bit.ly/Sharphound. So we have 5 minutes left, and Rohan's going to do something here.
So in the interest of open source, and since we like doing this, as of about an hour ago, the Sharphound open beta was available on our repository. It has pre-compiled binaries. You can just go up there and download it, or you can compile it yourself if you don't trust me for whatever reason. I don't know why. And that post I was telling you guys about, It's up on our on our SpecDrops blog. You can just check it out.
Oh,
I guess it's not displaying. Hold on, I got this. I hate you, PowerPoint. There we go. There you go. Hooray. Sharpound Open Beta, EXE, PS1. Everything works just the way it used to, except better.
All right, thanks everybody. That's our time, and I think we have time for questions, or no? We have 2 minutes. We have 2 questions. Answer 2 questions. Right there in the blue shirt. Yeah, so when his question was, have we thought about changing the password last set attribute? You could definitely do that. When you do this process where you're doing change NTL and mimikatz, that will implicitly be set by the directory service agent. For other purposes, you could just edit that attribute as well if you want. Yeah. Any other questions? I think we have one question. Yeah. That's a fantastic question. So his question was, when we set the NT hash back to what it was before, does that reflect in the NT hash history? The answer is yes, it does. So you could do one of 2 things. Either you could cycle through all of them and like